Okay, so in part 4, you're going to discuss how to recognize identities, conditional equations, and inconsistent equations. So give an equation, is it an identity, is it a conditional equation, or is it an inconsistent equation? Now the handout I gave you, it discusses types of equations. So these are the definitions. So these equations can be placed into categories that depend on their solution sets. So it depends on their solution sets. So an equation that is true for all real numbers for which both sides are defined is called an identity. So an equation that is true for all real numbers for which both sides are defined is called an identity. Let's look at the conditional equation. An equation that is not an identity but that is true for at least one real number is called a conditional equation. An equation that is not an identity, but that is true for at least one real number is called a conditional equation. And then an inconsistent equation is an equation that is not true for even one real number. So an equation that is not true for even one real number. Okay, so what I want you to notice is that in all the equations that we've done, either it was a conditional equation or an inconsistent equation. All right, so I want to make sure you understand why. So let's go back to, let's go back to part A. Let me just show you something. So we go back to part A, or part 1 rather. Part 1, remember when we solved these linear equations in part 1? So I had this equation right here. Now, notice there are no restrictions because the denominator is 1 in every case. So there are no variables in the denominator, so there are no restrictions. Okay, so this equation is defined for all real numbers. Now, the solution set, though, is a little different. So notice when I solved this equation, I only had one solution, x equal 9. So x equal 9. So since there was only one solution, then this is a conditional equation. So this equation is true only in the condition that x equal 9. So this equation is true in the condition that x equal 9. So there's only one solution, at least one solution. So remember the definition of a conditional equation. Conditional equation is an equation that is not identity but is true for at least one real number. So this equation is true for at least one real number, and that real number is 9. This is also a conditional equation because when I solve this equation, I got x equal 5. So 2 is a conditional equation. Now when I go to this one, all right, let's see, when I went to this equation right here, remember this rational equation? So remember this rational equation is defined for all real numbers except 0. Remember that was a restriction. All right, and so when I solve this equation, I got that this equation is true only when x equal negative 2. So that's a conditional equation. So x equal negative 2, there's only one solution, and that's negative 2. Now when I go to this one right here, remember this one, when I solve this rational equation, and I got x equal 1, but remember that was a restriction. So remember, let's talk about this definition of a inconsistent equation. So an inconsistent equation is an equation that is not true for even one real number. So the question is, when is this equation true? So in other words, when is this left side equal to the right side? Well, it never is, because when I solved for the variable and I got x to be 1, we found that that was a false solution. That was an extraneous root, so we said that was no solution. So therefore, this equation is an inconsistent equation. So there's no solution. So this equation is an inconsistent equation. Okay, so everything we've done so far has been either a conditional equation. So if you had a solution, it was a conditional equation. If you had no solution, it was an inconsistent equation. We haven't done any that was called an identity. We haven't done any. So let me just kind of go over a couple of examples of what an identity would be. Now, be a little bit careful when you look at this page. So x equal at least one real number. That should be at least one real number, but they say x equal a real number. Now, when you solved quadratic equations, you had sometimes you had two solutions. So you had two solutions. That would be considered a conditional equation. But this says equals a real number, meaning like one real number. But it could be more than one. Here, x equal all real numbers. Will be that's when we talk about identity. We'll come back to this. And then here, there's no real numbers, meaning no solution. That would be inconsistent equation. Okay. All right. So let's look at this example. So let's go ahead and solve this equation. So remember, you got to, in order to determine if an equation is one of these, you got to first of all solve it. Okay, so let's look at this problem. Number one, you have 3 times x plus 2 equal 7 plus 3x. So when I solve this equation, first of all, I got to get rid of these parentheses. I get 3x plus 6 equals 7 plus 3x. And then when I subtract 3x from both sides, I get 6 equal, and both of these, when I combine like terms, those are zeros here. So I get 6 equals 7. Now notice what happens. This situation where I solve this linear equation and the variable disappeared. I don't have variables any longer. So in that case, and notice that your statement, 6 equals 7, is that a true or false statement? Well, that's a false statement. So 6 does not equal 7. So in terms of your solution, what that means is that there will be no solution. So if I ask you what's the solution, you're going to first of all say the empty set. The empty set, or are you going to say no solution? Now remember, if it's the empty set or no solution, then you're going to say this is an inconsistent equation. So this is an inconsistent equation. So there's no solution. All right, number 2. So remember, this is a false statement. So the variable disappeared. So if the variable disappeared, look at the statement. If 6 equals 7 is a false statement, then that's the empty set, no solution. So this is inconsistent. All right, let's look at, let's see, let's look at this one, number 2. You have 8x minus 3x plus 2, in parentheses, plus 10 equal 3x. So 8x minus, in parentheses, 3x plus 2 plus 10 equal 3x. All right, so first of all, if I get rid of these parentheses, remember this is understood to be a negative 1. So if you need to distribute, you'll be distributing a negative 1 through here. So I get 8x, a negative 1 times 3x is a negative 3x. A negative 1 times a positive 2 is a negative 2, plus 10 equal 3x. Combining like terms, 8x minus 3x is 5x. A negative 2 and a positive 10 is a positive 8 equal 3x. And then if I subtract 5x on both sides, since I only have the constant on one side, this side, let's just bring the variables to the other side. So subtract 5x, and then combine like terms. This is 0. 0 plus 8 is 8 equal a negative 2x. And then when I divide both sides by negative 2, I get x to be a negative 4. All right. Now, remember, there were no restrictions. There are no restrictions. So x equal negative 4, assuming that this is correctly, that's your solution. So the solution would be x equal negative 4. And then if you ask yourself, what is it? Is an identity, conditional equation, or inconsistent? Well, since there's at least one solution, it's a conditional equation. So this is a conditional equation. So this equation is true only under the condition that x equal negative 4. All right, let's look at number 3. All right, number 3, you have, let's say you had, okay, let's say you had 7x plus 8 equal 7 times x plus 1 plus 1. Yeah. Okay, so if I distribute here, I'm going to get 7x plus 8 equal 7x plus 7 plus 1. And so I'm going to get, if I combine like terms here, I'm going to get 7x plus 8 equal 7x plus 8. And if I subtract 7x from both sides, notice what happens. The variables disappear also. But this time, I get the statement 8 equals 8. Earlier, I got the statement 6 equals 7. That was a false statement. So if it's a false statement, the variables disappear, and you end up with a false statement. Because 6 can never equal 7. Then your solution is going to say no solution, and it'll be inconsistent. If you get a statement that is a true statement, 8 does equal 8, so that's a true statement, then the solution, now remember there were no restrictions because there wasn't anything in the no variables were in the denominator, so there were no restrictions. So since there are no restrictions, the solution will be all real numbers. All real numbers. That's your solution. And so if it's all real numbers, then that would be an identity. So this equation is an identity. Okay, so if it's all real numbers, you're going to say it's an identity. Now, what that means is that no matter what I plug, no matter what number I substitute into x, I don't just want you to understand this. So make sure you understand this. So my original equation was 7x plus 8 equals 7 times x plus 1 plus 1. So what I'm saying is that any number works. Any number works. Any number, all real numbers is the solution. Decimals, fractions, irrational numbers, rational numbers, any real number is a solution. So if you want to try, let's say x equal 1, is x equal 1 a solution? So where we see x, you plug in 1. So I get 7 times 1 plus 8, and I want to see if that's going to equal 7 times 1 plus 1 plus 1. So we saw the variable x, I plugged in 1. 7 times 1 is 7. 7 plus 8 is going to be 15. Over here, that's going to be 7 times 2 plus 1. And that's 14 plus 1, which is 15. All right, if you try x equal, let's say, 5. So is x equal 5 a solution? Well, plug in 5. So you can get 7 times 5 plus 8. And we'll see if that's going to equal 7 times 5 plus 1 plus 1. So 7 times 5 is 35. And 35 plus 8 is going to be 43. Over here, that's going to be 7 times 6 plus 1. So that's 42 plus 1, which is 43. So notice, if you keep on, you'll see that the left side will always equal the right side no matter what number you plug into x. So it's all real numbers. So again, if you solve this equation and you end up, and the variables disappear, and you end up with a false statement, then you say no solution, and it's inconsistent. If you solve this equation and you get x to be at least one solution, then you do have a solution. If there's no restrictions, you do have a solution. It will be that restriction. That solution. And then you say it's a conditional equation. If when you solve the equation, the variables disappear, and you end up with a true statement, then you're going to say all real numbers. And then this would be a conditional, this would be an identity. All right, now let's look at this one. Number 4. Okay, suppose you had 2 divided by x minus 2 equals 3 plus x divided by x minus 2. All right, so first of all, let's look at the restriction. So the restriction is that x is not equal 2, because 2 makes both of these denominators 0. And that's the only number that you can't use. So I can I can substitute any number into the variable except 2. Now, we got to find the solution. That doesn't mean that your solution is all real numbers. But in terms of where's these rational expressions defined, they're defined for any real number except 2. But we got to find out which one of those is the solution, if any. So the LCD, we don't have to factor. It's already, you can't factor the x minus 2's. So the LCD is just x minus 2. So you can multiply both sides by x minus 2. So I get x minus 2 times 2 over x minus 2 equal, and over here, since these have more than one fraction, put that in parentheses, just like this, and we say times x minus 2. Alright, so the next thing you're going to do is you're going to take this x minus 2 and you're going to distribute. So just like you've been doing before. Now over here, these x minus 2's divide out, and so you're just left with 1. I'm sorry, 1 times 2, which is 2, equal. Over here, and be careful, you're going to say 3 times x minus 2 in parentheses, just like this, plus, and then this LCD times this fraction, x minus 2 times x over x minus 2. And then you're going to distribute here, and then over here, you're going to reduce, just like this. And so you can get 2 equals 3x minus 6. 3 times x is 3x. 3 times negative 2 is negative 6. Plus x. Combining like terms, I get 2 equals 4x minus 6. Adding 6 to both sides, I get 8 equals 4x. To get x by itself, I'm going to divide both sides by 4. Just like this. And so I get 4 divided by 4 is 1. 1 times 1 is x. Equal, and 8 divided by 4 is 2. But remember, that is a restriction. So this is an extraneous solution. So remember, when you did this, you said the solution, you said the empty set or no solution. Alright, so if you have, just like when we did here, so if you say no solution, then this is inconsistent. Now over here, the variables disappeared. Here the variable did not disappear. Okay, so don't say this is don't say this is a conditional equation, because this 2 is an extraneous solution. It's an extraneous root. So you really say no solution, and then you say this equation is an inconsistent equation. Okay. All right, and then let's try and do one more. Let's look at let's see. Let's do this one. It's going to be number 5. All right, you have 4 divided by x minus 2 plus 3 divided by x plus 5 equal. So 4 divided by x minus 2 plus 3 divided by x plus 5 equal 7 divided by x squared plus 3x minus 10. Alright, so before you find your restriction, you got to factor your denominators if possible, and I can factor this one. So I can factor this as x plus 5 times x minus 2. And always check yourself. X times x is x squared. The outer's a negative 2x. The inner's a positive 5x. When I add them up, I get 3x. And then 5 times a negative 2 is a negative 10. So my restriction is that x cannot equal... Okay, so when I set this denominator equals 0, I get x equal 2. So x cannot equal 2. When I set this denominator equal to 0, because remember I'm trying to find what makes it 0, I get x be negative 5. And so x cannot equal negative 5 or negative 2. If I set this factor equal to 0, that's this one. I've already done it. This factor I've already said equals 0. And so I've already done that one. So there are 2 restrictions. Now the LCD in this case will be x plus x minus 2 times x plus 5. So you can multiply both sides by this LCD. So we're going to say LCD times the first times the left side just like that, equals the LCD, x minus 2 times x plus 5 times that right side, which is just one fraction. Again, don't write the denominator as x squared plus 3x minus 10. Write it in the factored form. X plus 5 times x minus 2. All right, and then what you're going to do now is you're going to distribute. And so I'm going to get this LCD times the first fraction plus the LCD times the second fraction equal. And over here, these x plus 5's divide out, the x minus 2's divide out, and you have 1 times 1, and then 7 over 1 is just 7. So that's just 7 over here. And over here, if you reduce, the x minus 2's divide out, and you get 4 times x plus 5, with the x plus 5 in parentheses, plus, and over here, the x plus 5's divide out, and you get 3 times x minus 2, and put x minus 2 in parentheses, and that's equal to 7. And then distributing, I get 4x plus 20 plus 3x minus 6 equals 7. Combining like terms, 4x and 3x is 7x. 20 and a negative 6 is a positive 14 equal 7. Okay, so notice I went from a rational equation to a linear equation. So I'm going to solve this linear equation. So I'm going to subtract 14 from both sides. Combine like terms, I get 7x equal a negative 7. To get x by itself, I'm going to divide both sides by 7. 7 divided by 7 is 1. 1 times x is x. A negative 7 divided by positive 7 is a negative 1. Now notice that I solved this equation and I got negative 1. And I notice that negative 1 is not a restriction, so I have a solution. I have at least one solution, one real number. So my solution is x equal negative 1. Now since I have at least one solution, we're going to say this equation is a conditional equation. All right, so this equation is a conditional equation. All right, so in summary, if you have no solution, you're going to say it's inconsistent. Whether or not you got it from solving a linear equation where the variables disappear and you get a false statement, or where you have an extraneous root. It doesn't matter. It's going to be an inconsistent equation. If you have a solution, at least one solution, then it's called a conditional equation. All right, now, if your solution is all real numbers, then your remember 8 equals 8. So the variables disappear, you got a true statement, and so we say all real numbers. Then you're going to say this is an identity. Okay? Now, one other thing I've just got to mention to you, it was mentioned here, and I just want to make a note of it right here. Oops. It was mentioned here. So let's talk about this for a moment. So I'm going to just go ahead and call this number 6. Number 6. We had 2x divided by x equal 2. 2x divided by x equal 2. So notice the restriction, this is a rational equation, so the restriction is that x cannot equal 0. Because if x is 0, that makes this denominator right here 0. It doesn't matter what the numerator is, as long as the denominator is not 0. And so the LCD would be x. And so if I multiply both sides by x, just like this, and then simplify, so these x's divide out, and so I get 2x equal 2x. Just like that. And if I subtract 2x from both sides, so notice I went from this rational equation to a linear, so bring the variables one side, constants to the other. But if I subtract 2x from both sides, notice what happens, I get 0 equals 0. So just like over here, when I had 8 equals 8, that was a true statement. I said all real numbers. Okay? Over here, though, it's a little different. This is a true statement. True statement. But I can't say it's all real numbers because I had a restriction. So it's not all real numbers because 0 doesn't work. Because 0, I get 0 in the denominator, it's undefined. So my solution, you would say this. You would say the solution is, and I think on my math lab, if we can find it, they put it in set notation. So they may say this. They may say the solution would be the set of x's, such, I remember last semester you used this notation, set of x's such that x is a real number, and you would say x cannot equal 0. So that would be your solution. All right, so in my math lab, I think they used this notation. So a set of x's such that x is a real number and x is not equal to 0. Now, you could say this on the test. You could say the solution, you could say all real numbers except 0. All real numbers except 0. All right, so remember over here, you said all real numbers because there were no restrictions. Notice there were no variables in the denominator. So you said all real numbers. Over here, you're going to say all real numbers except, you got to be careful because there was a restriction. All real numbers except this restriction, except 0. And set notation looks like this. Set of x's such that x is a real number and x cannot equal 0. Your restriction. Now, remember, an identity, let's go back to the definition of an identity. An identity is an equation that is true for all real numbers for which both sides are defined. All right? So both sides are defined for all real numbers except 0. That's what that means. So both sides are defined, so I can plug in any number for x, and this side is going to be a number, and this side is going to be a number. Well, there's no variable there, so this is always going to be 2. But the only one that makes this side true is all real numbers except 0. So, for example, if I plug in 5, 2 times 5 is 10. 10 divided by 5 is 2. 2 equals 2. If I plug in 3, 2 times 3 is 6. 6 divided by 3 is 2, and 2 equals 2. So everything works except 0. So this is called an identity. So this equation is an identity. So if you see anything like all real numbers except, it's an identity. If you see all real numbers, it's an identity. Okay? All right, so just want to make a note of that. You may see something like this on my math lab. All right, so that's going to take care of this lesson.